divide by 5, that's going to help you so that you're dealing with smaller numbers. You don't want to do 5 to the 4th power, okay? That's going to be, I think, 625. So save yourself that pain. Divide both sides by 5. Then you can raise each side to the 4th power to get 6x plus 1 equals 16. Okay, and then you'll reduce, so 3 goes into both to get 5 over 2. Now, when you do the check, if you have a fraction, don't be afraid of to do the check with the fraction here. Remember, you multiply the whole number by the top, divide by the bottom. 6 times 5 is 30. 30 divided by 2 is 15. 15 plus 1 is 16. 16 to the 1/4 power is the same thing as doing what? Taking the 4th root. And the 4th root of 16 is 2. 5 times 2 is 10. Yay, it works out. Okay, and then look, this side you just drop down your 10. You don't have anything to simplify. Alright, for this one it's very similar where you want to start by dividing by 4. Are some of you squaring right away? You could do that, but then you're going to have 16 on the outside times this. And then on this side you'll have 16x. So be careful. That means you're working with larger numbers, and this is your no calculator section. So if you can divide both sides by 4 right away, you'll have 7x plus 18 to the 1/2 equals x. Then you can square both sides to undo the power. You'll have 7x plus 18 equals x squared. And then when you have an x squared and an x, that should be your hint that everything's going to one side so you can factor. I like to move everything to the side where positive x squared is to make it easier to factor. Okay, and then your factors are x minus 9, x plus 2. Negative 9 plus 2 is what adds to negative 7. So x is 9 or x is negative 2. And then I plug it back in to check to see if I have anything that's extraneous. So when I plug in 9 on both sides, this side is really simple. 4 times 9 is 36, so not doing anything else. And again, you can't divide both sides by 4. You can't do operations because you don't know if they're equal. Okay, that's what you're checking. So we know 7 times 9 is 63. When we add that to 18, we get 81. Remember, 81 to the 1/2 is the same thing as taking the square root. So the square root of 81 is 9. 9 times 4 would be 36. Okay, so that's going to check. Okay? All right, so make sure that you're showing your proper steps here. When you check the negative 2, 7 times negative 2 is negative 14. Add that to the 18, which will be 4. Again, this is the square root. Square root of 4 is 2. 2 times 4 is 8. But then if you go back here, 4 times negative 2 is negative 8. Okay, so those will not be equal. Okay, so on your line, it's only x equals 9. And then, of course, this is what we call an extraneous solution. Okay, and I will post a video of this, so if you guys need to go back and add anything to your checks to make sure you get that part on your quiz, you're good. Let's look at 11 and yeah.
Can you go over the check for 12?
Yes. Yep. And then do you guys need to see anything else besides the check for that? For 12? Yeah. Yeah.
The problem says 1/2, but in the 1/2, we always have to write it as that. It's not as good as the square root.
Yeah, you can write it as the square root. Yeah, that's fine. Yep. And then do the square to both sides? Absolutely. Yep, you can interchange those two. Okay, so for 12, so you're good with the x equals 47, you just want to go over the check, right? Okay. Yes. So on this side we have 3 times, and then I'm just going to plug this in for x equals 18. Okay, so the only side I have to simplify is this one. So 47 minus 11 is going to give you what? So 7 minus 1 is 6, 4 minus 1, 36. And then what's your square root of 36? Yep. So then you'll get 18 equals 18, and you'll be good. Yes. So that's exactly what this should look like for 12. So make sure you have those proper steps right now, okay? Yes, for 13, and then, but getting the answer of 7 is fine. I do want to go over, because this is your no calculator section. If you're having trouble with 3 to the 4th, just write it out 4 times so you can see this is 9 times 9, okay? The 81, and then you subtract, divide, x equals 7. All right, now let's do the check. I just remember it's a good thing to help you when you don't have a calculator. So 10 times 7 plus 11 equals 3. So you can't do operations to both sides. You cannot do the 4th power to both sides. You only can simplify one at a time. So this is 70 plus 11. So you'd have the 4th root of 81, which is 3. Okay, so you can see the one that we did with the radicals was a little more intensive, but this is what you have for 13. Now that you've seen a few checks, how do you guys feel like those are going for you? Okay. Oh, good. Yeah, so you wouldn't need a check for 11. You would need a check for 12 and 13. We just went over those. Okay, 14 is x is 9. These are okay? These two? Okay. Let's look at 15 and 16. We would need checks for both of those. And you would have to check both of them. Actually have them right now if you want to see them real quick. So, for so for 15, your check, the negative 2 plus 2 equals negative 6 plus 6, square root of 0 equals 0. Those two are equal. Oh, my bad. Sorry. And then you check for 1 when you plug it in. We get 3 equals 3. And then for 16, you have the 1/2, so 50 minus 25 to the 1/2 is 25 to the 1/2, so 5 equals 5. These two are different figures at the bottom. All right, and then, okay, so then for the inequalities, if it's an even root, it has to be positive under the radical. That's when you do your 2 steps. So for this one, you're going to subtract 2 to both sides, square it. You get x is less than or equal to 5. But then you also have to have this be positive. If it wasn't, you get an invalid solution. So these two things have to happen at the same time. X has to be less than or equal to 5. And x has to be greater than or equal to negative 1/3. So 17, you have to do the 2 steps because it's an even root. Sometimes with number 18, I think people start to second guess themselves because they feel like it's too simple. But if it's a cube root, you don't have to do step 2. So if it's a cube root, you can take the cube root of any number, any real number, you can take the cube root of. So all you have to do is solve it. Cube both sides, x is greater than 9. You do not have to do this step. So again, it's the even roots with the restrictions that it has to be positive, which is why these two things have to happen at the same time. But a cube root does not need that. Okay?